Hello friends, in this lecture we are going to see how to find shortest distance between two curves. We will also use coordinate geometry and some bit of calculus to manage this. People who don't know me, I am Vinay Kumar, teaching JEE aspirants since last 22 years. For more details you can visit my website vkrclasses.com. So let's start. Now, we have a concept here that whenever you want to find shortest distance between two curves, the shortest distance is found along the common normal between the two curves. Common normal will be the direction in which the shortest distance will be found. Even the longest distances can be found along the common normal, because as a basic concept you can see that when suppose we have two circles like this, okay, placed like this, you can see that if you join the line joining the centers, this is a common normal, isn't it? So if you use these 2 points A and B, this will create the shortest distance between the two curves. And if you use point C and D, then the longest distance will also be found along this common normal. Okay, so common normal is actually a situation where you can get both this minimum distance as well as the maximum distance. All right. Now let's see the question here which we have picked up. Find a point on the circle x square plus y square equal to 1 which is at the shortest distance from the line this. So this is a circle here, x square plus y square equal to 1, okay, and this line is somewhere like this, 3x plus 4y equal to 12. All right. Now when we want to find the shortest distance, we will go for a common normal like this. Now how do we discuss a normal here? For a line it is a perpendicular, and for a circle a normal is a line which passes through its center. Okay. So if this is passing through center, so we are mainly interested in finding out these 2 points A and B between which the shortest distance will be found. Okay. Now here they are not asking the distance we can find, but here they are asking that you find a point on the circle. That means we are interested in getting the coordinates of A, by which we are getting the shortest distance. All right. So what we will be doing here is we will take the help of this line. This line has a slope of minus 3 by 4. So for a perpendicular line, we have a slope of m equal to 4 by 3 because it is perpendicular to this line. All right. So with a slope of m equal to 4 by 3, we will move ahead from origin using parametric coordinates to get the coordinates of A. Now the distance traveled OA is its radius, which is equal to 1, and tan theta for us here is 4 by 3. So cos theta and sin theta we can find and get the coordinates of A. To get the coordinates of A, we need x is equal to r cos theta and y is equal to r sin theta. All right. So here we are, r is 1, this is your r 1, and tan theta is 4 by 3, from where we can get cos theta. The cos theta is 3 by 5, and here y will be found as 4 by 5. So the coordinates of A that we have found is 3 by 5 comma 4 by 5, right? And if you want to get the distance, you can find the distance from origin to this line. How much is the distance of line from the origin? So let's say OB, if you find that quantity is 12 by 5, okay, and if you subtract the radius out of it, OA is the radius, so you will get the shortest distance. The shortest distance, even if they have not asked, if we find shortest distance will be AB, and that will be the total distance 12 by 5 from origin to B, and minus the radius, that is 1, that is 7 by 5. So this is your shortest distance, and the point A has been found here. This is the requirement of the question. If you want to get the point B, you can find the foot of perpendicular from origin to that line. that will also generate the point B. Okay. So this is the process. We use the common normal because here if you see, this tangent is parallel to this line and this is a common normal. This direction is along which we have found the shortest distance. Okay. Let's see another example. Find a point in the circle which is at the shortest distance from the circle. That means there are two circles here and we have to find the shortest distance between them. The second circle is centered here at 1, 0, having a radius of 1, and the first circle is somewhere here centered at 3, 4 and having a radius of 2. All right. Now what we are interested in is finding a point on the second circle, okay, which is at the shortest distance from this circle. Now obviously we told you earlier that we have to go along the common normal. The common normal will be a line joining the two centers. Okay. So is the center is this one and this one. We have to join the two lines. This will be the direction of common normal, and here we have to find the shortest distance. So we will be interested in this point and this point at which the common normal intersects the two circles internally. And here we have to generate the coordinates of B. In this, according to our question, we have to generate the coordinates of B. Okay. Now from the line joining the two centers, we can get the slope. The slope is how much? 4 minus 0 upon 3 minus 1, that is equal to 4 by 3, that is 2. 4 by 2, that is 2. Okay. This will give us the inclination tan theta at which we should travel from C1. And how much distance we have to travel? Let's say we find out the distance from C1 to C2. How much is the distance between C1 to C2? C1 to C2 is equal to 4 minus 1 square and 3 minus 1 square, 2 square plus 4 square. Okay. So this is equal to 2 root 5. All right. This is the total distance from C1 to C2. All right. If you subtract this distance from here, which is its radius 2, and we subtract this distance from here, we will be able to get the shortest distance. Suppose we are interested in the shortest distance. Suppose we are interested in shortest distance, that is given by AB, and that will be equal to how much? This total distance 2 root 5 minus this radius 1 from here and this radius 2 from there. So this is the shortest distance that we have. Suppose we have to get the coordinates of B. Will travel a distance of C1b. How much is C1b? C1b is equal to total distance C1 C2, which was 2 root 5 minus that radius 2. This distance we have to travel from C1 to reach the point B. All right. So what we will do is we will take the slope into account and use parametric coordinates. Okay. So get the coordinates of B. What I will do? I will use 1 plus r cos theta. So how much is the distance C1b? This much. 2 root 5 minus 2. This is the total distance travelled. Cos theta. Cos theta will come from here. Cos theta is how much? 1 by root 5. All right. 1 by root 5. So we can simplify this. How much we are getting? We are getting 2 minus 1 by root 5. All right. No, this is not 2. This is 2 plus 1, 3. 3 minus 2 by root 5. All right. Now what about the y coordinate? Y coordinate is 0 plus same distance 2 root 5 minus 2 sin theta. Sin theta is how much from there? 2 by root 5. So this is how much for us? This is 4 minus 4 by root 5. So we have got the coordinates of B here. Okay, we have got the coordinates of B. We can write it here. 3 minus 2 by root 5, comma 4 minus 4 by root 5. This is the coordinates of B. We can similarly get the coordinates of A also. If you wish, you can travel a distance of 1 unit from this point and get the coordinates of A at this slope of tan theta equal to 2. All right. Find a point on the circle this which is at the shortest distance from the pair of lines. Now we have to get these lines in factorized format. Suppose you factorize it, you will get the lines as 12x minus 5y into 3x plus 4y. That you can do it on your own. Let me check once. Is it giving us that situation? Yes, I think so. Now, where is our circle? We will first plot the lines and the circle. So, this line is somewhere like this, 12x plus 5y. This is your line 12x minus 5y equal to 0. And this 3x plus 4y will have a negative slope, something like this. And where is our circle? Our circle is at 6, 4, somewhere here. Centered at 6, 4 with a radius of 1. Alright. So, in this case, they are asking, find a point on the circle which is at the shortest distance. So, we don't know whether which point is at the shortest distance. So, maybe we will drop a perpendicular here and check this distance, compare it. We will try to find out which one is smaller. Alright. So, suppose this point is A, this is B, and this is M, this is C, and this is N. Okay. So, first thing we need to find out whether this distance AM is smaller or the distance AN is smaller. That is what we want to compare. So, if you find AM first, AM will be how much? Distance from 6, 4 to this line. So, 12 into 6 minus 4 into 5 by 13, which is equal to 52 by 13, which is 4 units. So, AM distance is 4 units. We want to compare it with AN. How much is AN? 6 into 3, 18 plus 16 divided by 5. How much is this? This is 34 divided by 5. Now, this distance is bigger, you can see. AM is lesser than AN. Alright. So, obviously, our shortest distance is being found from B to M. So, BM will become your shortest distance. This is your shortest distance because B will be found nearer to this line. So, they asked find the point on the circle. So, we want to get the coordinates of B. Okay, we will get the coordinates of B because it is definitely at a shortest distance from this line and this line pair itself. So, we will get the angle here. So, this slope theta will be how much? It will be perpendicular to this line. This line has got a slope of 12 by 5. So, this tan theta will be measured as minus 5 by 12. Okay, and we will use parametric coordinates, travel from A to reach B. Okay. So, if you write the coordinates for B, x will be equal to 6 plus r cos theta. R is 1. 1 cos theta will be equal to how much? Minus 12 by 13. Alright. And y will be equal to 4 plus 1 sin theta. Sin theta will be 5 by 12. As you know, this is obtuse angle, so cos theta will be negative and sin theta will be positive. So, this is our required coordinates. You can calculate 78 minus 12, that is 66 by 13, and this is 48 plus 5, 53 by, no, this is not 12, this is 13. So, 13 into 4 is 54, 54 plus 5 is 59 by 13, alright. So, our final coordinates required is 6 by 13, comma 59 by 13. Do you get this? So, the whole of the pair of lines, the shortest distance of this line will be AM and the shortest distance of this line will be AN. Obviously, the perpendicular will form the shortest distance. We will compare the two, whichever is smaller, we will focus on that. So, our distance AM is smaller. So, shortest distance will be created between the point B, which is in the circumference of the circle, and the foot of perpendicular. So, BM is the shortest distance. That can also be found because we have already seen in the earlier question that we will find the distance from 6, 4 to this line and subtract the radius. That will give you the shortest distance. Alright. Let us see another example. find a point on the sides of the triangle formed by the lines. Now this line has got some problem. We have this line, y plus 2 equal to 0. There should be a correction here. So we have these three lines which is forming a triangle, and we have to find the shortest distance from this circle. So let's draw the lines first so as to understand where is the triangle. So this line is y plus 2 equal to 0. So this is minus 2. This is 4x minus 3y, somewhere like this. And this line is 5x plus 12 with a negative slope, something like this. 5x minus 12y minus 48 equal to 0. Alright. Now, where is the circle? The circle is centered at 3, 1. Okay. Please find out. And what is the radius? Radius is 1. So we will draw 1 unit radius here. The radius is 1. Now, we have this triangle formed. This is triangle A, B, C. And what we are looking for is the shortest distance of the circle from the lines. Now we have to choose which distance is shortest. Now obviously this is very easy to find out. This distance is equal to 1 plus this 2, that is this distance is totally 3 here. We will find out this distance as well as this distance. So let's say this is C and this is P, this is Q and this is R. So CR we have found, this is equal to 3, and from the figure itself let's find CP. The CP is equal to how much? Let's place 3, 1 into this line. So this is 12 minus 3 divided by 5. So this is 9 by 5. Alright. And we'll find CQ. CQ is equal to how much? We'll place 3, 1 there. So 15 minus 12. No, this was 15 plus 12, I think. So 15 plus 12 minus 48 divided by, we generally use mod here, 13 mod. So how much is this distance? 27 we have to subtract. So this is 21 by 13. Now you please compare which distance is smaller. This is around something more than between 1 and 2. This is also above 1. And this is 3. So which is the shortest out of all them? I think CQ is the minimum distance. Is the shortest perpendicular that we have got. This is not the distance. Excuse me. Now, the shortest distance will be created where? I think it will be created here because CQ was the smallest one. You compare these two. So we are interested in this distance. This distance is going to form our shortest distance. Okay. All right. So which point they are interested in? Whether they are interested in the point on the circle or on the line. Let's find out. They want a point on the sides of the triangle. Okay. So sides of the triangle, they are interested in the point Q. So what we will do is, we will draw perpendicular from C onto that line, and that will form our foot of perpendicular. So how do we calculate foot of perpendicular? From C on the line 5x plus 12y minus 48 equal to 0. So we have the formula for foot, x minus 3 upon 5 equal to y minus 1 upon 12 equal to minus, we will put this coordinate into the line, 15 plus 12 minus 48 upon this square by this square, which is 169. All right. If you solve this, you will be able to get the coordinates of Q. So I think you can simplify. This one will calculate first, and then we'll calculate from here. So this will give you x and y both. So that will form the coordinates. All right. This is 21 by 1. X can be calculated like this. 3 plus 5 times 21 divided by 169 with a minus sign. All right. And how much is y? This you can simplify on your own. How much is y? 1 minus 12 into 21 by 169. Alright. So this is the point that we have found on the side of the triangle, which is Q here, which is at the shortest distance from a circle. And this point is maintaining a shorter distance from this position. This point, let's say we can call this point as L. From L it is maintaining a shorter distance. LQ is the shortest distance. Okay. Find the shortest distance between the circle and the parabola. So let's draw the circle and the parabola. Parabola is shifted here. It is somewhere like this. At its vertex is at 0, 12. All right. And this circle x square plus y square is here. X square plus y square equal to 1. So what we are interested in is the common normal. This is the concept. The common normal will go like this. It will be perpendicular here as well as here. This distance AB will be the shortest distance. Okay. So they are interested in finding the shortest distance. So if we catch point B there, that will be helpful in getting the shortest distance, because we will subtract the radius from OB. Alright. So what we will do, we will write the equation of normal there on this curve. How do we write the equation of normal? Equation of normal at B on the parabola. A B point can be chosen like this. How do you calculate with a shift here? We write the equation like this, y minus 12. The formula is y is equal to mx minus am. A is 1 here, minus 2am minus am cube, isn't it? M is 1 here. So this is the equation of normal at B. And what is the data for B? The data for B is like this. It is am square, a is 1, so it is m square, and comma minus 2am. Minus 2m is minus 2m, and this 12 we have to adjust, so it will be plus 12 there. Okay. So this is the coordinates for B at which we have drawn the normal. What else we can do is, we can also use calculus to generate the equation of this line at this point. Alright. I have taken a parametric coordinate at B, and then you can calculate. Let's see. This line is supposed to pass through origin, because that is the position where the normal to the circle passes. So put 0, 0 here. So if you put 0, 0 here, what do we get? Minus 12 is equal to minus 2m plus m cube. This will give us what? This will give us a cubic in m. 2m minus 12 equal to 0. On trial you can find a root. So I think m equal to 2 is working. M equal to 2 is working as a root. So you can factorize and get more values of m. But whatever values of m we will get, you can see from here, this has got, you know, Descartes' rule of sign. If you use Descartes' rule of sign, you can see that the value of m that will be given from here will have maximum 1 positive root, isn't it? So if it has a maximum 1 positive root, what will happen is, since we are going close to this parabola, this m, okay, this m we need to be positive, because if m is positive, it will be on this lower branch. If m is negative, it will go on the above branch. So obviously, if any normal is going above, that will create a longer distance from the circle. So we are interested in a positive value of m. Negative value of m we are not interested. Even if there is a negative value, you can find out, but that is a waste of time. So for get shortest distance, we use only m equal to 2 here. There is no other positive root using Descartes' rule of sign, because the coefficients are changing like this, plus, plus, minus. There is only one positive root possible, and we have got it by trial. So we need not solve it again. Okay. So need not factorize. You can factorize and check for yourself. If m is equal to 2, what is happening? We have got the coordinates of B. Put it here. So it is 4, comma, how much? 8. All right. So we have got the coordinates of B. Once we have reached B, to generate the shortest distance, what we will do is, shortest distance is AB, isn't it? Shortest distance is equal to AB, and that will be calculated as OB minus OA, which is its radius. OB is how much? We can calculate from origin, this distance of this point 4, 8, that is under root 4a square plus 8a square, and radius is 1. So 4 will take common, so it is 4 root 5 minus 1. So this is the shortest distance between the circle and the parabola. And we can also generate the coordinates of A also if you are interested, but that will take parametric coordinates, and we can use the slope of this line to generate A. Now, if you see this is not talking about any curve. This is a distance formula between 2 points. Let us say what points they are talking about, x1 and 2 root x1. This is a square of a distance. So let us say we have this point, another point is like this, x2 comma x2 square plus 39 upon 4. All right. So if you use this, in the form of curves, how this is sitting on this curve, y equal to 2 root x, and what is this doing? This is sitting on this curve y equal to x square plus 39 by 4. So we can draw it like this. Okay. And now again we are interested in getting a common normal here. All right. You are interested in getting a common normal here. Now, for this curve, if you want to go to your parabola, this may be extended and created like this. You can square it, y square equal to 4x. This is our standard parabola for us. Now again we want to create a normal here. Okay. So if I differentiate this and get the slope of the normal for this curve, this one I can use on a standard basis. I have the normal for this standard parabola. So let us say the normal is, let the normal at A, let us say call this point as A and this point as B, y equal to mx minus 2am minus am cube. A is 1 for us. So this is the equation of normal at A. And what is the coordinates of A here? The coordinates of A is am square minus 2am. Okay, I have written this. You can also differentiate this and create this normal. All right. Now what about this point B? At point B, we can take a coordinates like this, parametric coordinates like this. This may be shifted, but I will do it on a simple basis. I will take x as v, and this y will be v square plus 39 by 4. Okay. So what I will do is, I will get the slope there. So dy by dx of that curve will be equal to how much? X by 2. You can differentiate. Okay. And at v, it will be dy by dx at v will be, at that point B will be equal to how much? It will be equal to v by 2. All right. For the tangent, this is the slope of tangent. For what about the slope of normal? Slope of normal will be minus 2 by v, perpendicular to the tangent. All right. This slope has to become equal to this m, because this is the same line which is going there. So this is also equal to m. This is a condition that we have got. Now what? We will write the equation of normal, which we have already done, and put b on this. So if I put b, coordinates of b on this, what I will get? Coordinates of b is v square plus 39. So I will actually replace v by m. Okay. So I will replace v by m. But let me put it first. V square plus 39 by 4 equal to mv minus 2m minus m cube. What we have got? A mixed equation in v and m. So first of all, we have to replace v here. So v will be equal to minus 2 by m. All right. So if I replace the value of v here as minus 2 by m, what do I get? I get, let me create some space here. V square by 4, that means equal to how much? V square by 4 will be equal to 1 upon m square, alright, plus 39 by 4 equal to mv. mv will be equal to minus 2, minus 2m. So I will reciprocate it. M I have found. No, minus 2m is there, so I did not change. Minus 2m minus m cube. Alright. So we have this fifth degree equation with us. So this is again, we cross multiply. 1 plus 39 by 4 m square is equal to minus 2m square minus 2m cube minus m5. So bring it this side. m5 minus 2m plus 2m cube minus plus 39 by 4 plus 2 m square and plus 1 equal to 0. Okay. All right. Now, if you take LCM, you will see that the coefficient here coming up is 4. If you take LCM, it will become 4m5 plus 8m cube plus 47 m square plus plus 4 equal to 0. All right. So you try to find out roots using the factors here. Okay. So if you go on trial, you will find that the value of m found will be minus 2. Now you can see in this expression that a positive value of m is not required. We want a negative value of m because this is sitting in the first quadrant, isn't it? This is sitting in the first quadrant. So here we will get this position where we can get a root. You can try like this, that all these coefficients are positive. So obviously negative value of m is the one which will give us a root possibly here. So it's up to you. I will leave it to you to check whether the other roots are working or not. But as a concept, I can again tell you, here also you can use Descartes rule of sign to understand that the value of m, there is only one value of m which is negative, and that is going to help us in this first quadrant. Okay. So at the value of m, we can get what? Using the value of m, we can get v also. The v is how much? V is equal to, put the minus 2 there, v is equal to 1. So this will create a for us. A is 4 comma 4 again, and b is, put v equal to 1 there in the coordinates here. So this is 1 comma 10. All right. So for our case, we have understood that we are requiring not the shortest distance. This minimum value of this is actually in the form of distance square. So this is AB square. That means we have to find the minimum value of AB. A is sitting on this curve and B is sitting on the other curve. So we want to find the minimum distance as AB square, and AB square is equal to how much? 4 minus 1, 3 square plus 6 square. So it is how much? 36 plus 9, that is 45. All right. So if we want to distance, it will be under root of 45, but right now we need the square of it because this is distance square. Okay. So this is going to form our answer. All right. Let's see another example. Find the point on the curve. This is a hyperbola, x square by 24 minus y square by how much? 18 equal to 1. All right. So if you draw this hyperbola, it is something like this. All right. And this line 3x plus 2y plus 1 is something going like this, 3x plus 2y. It is cutting the axis below it, below origin, all right. Now we want to find out the point on the curve which is the nearest distance to it. Now again we will draw a normal here. A normal can be drawn like this. A normal can even be drawn like this. Okay. What we can do here is, we can even say that this tangent is going to be parallel to this line. Now this line has got a slope of minus 3 by 2, isn't it? So with this slope, we can even write the equation of tangent at this point. So let's say A and B. We are picking up 2 points and we'll try to compare the distance from both sides. All right. So let's say we are picking up a point here A as x1 comma y1. All right. For the moment, let us consider x1 comma y1. Now this x1 comma y1 will satisfy our curve equation. Okay. And another thing, we can get the slope of the tangent there. How do we write the equation of tangent at A? And we can write it like this: x1 3x1 minus 4y1 equal to 70. This is the tangent at A, and its slope is how much? 3x1 by 4y1. All right. This slope should match with the slope of this line, because this is the normal, we have a parallel tangent. The tangent is parallel to this line. So this will be equal to minus 3 by 2. We have equated the slope of tangent with this slope of the line. This will give us y1 is equal to minus x1 by 2, isn't it? Cancel 3, cut 2 there. So we'll get y1 equal to minus x1 by 2. This y1 will place it here into this equation. So this becomes 3x1 square minus x1 square equal to 72, by which we can get x1 as plus minus 6. All right. And from here we can get y1 as minus plus 3 in order. Okay. So we have created the two coordinates. A is, let's say it's sitting in the fourth quadrant, so it is 6 comma minus 3, isn't it? And how much is B? B is minus 6 comma 3, because it is sitting in the second quadrant according to our figure. Now we don't know which distance is shortest. Okay. So what we will do, we will compare these distances. We will try to find AM and we will try to find BN. So if you compare the distance, then we can understand which normal is creating the shortest distance. Because a normal creates the shortest distance in its area, there can be several opportunities. We have to choose the smallest out of all of them. So how much is the distance of A from this line, 6 comma minus 3, to this line? So put 6 comma minus 3 there. So it is 18 minus 6 plus 1 upon root of 13. So this is equal to how much? 13 by root 13. All right. And how much is Bn? Bn is, this point was 6 comma minus 6 comma 3. So it is minus 18 plus 6 plus 1 upon root 13. Isn't it? Put it there. So once we get this, what we are getting here, this is getting 11 upon root 13. So obviously we can see Bn is smaller than Am because the numerator is smaller. So Bn is going to form the shortest distance. All right. So the shortest distance found is 11 by root 13. But we are being asked to find the point on the curve. So the point on the curve chosen is B, and this was minus 6 comma 3. So our answer would be 6 comma minus 6 comma 3. Out of the two normals, this one is creating a shortest distance for the whole of the curve from the line. All right. So this is the situation. So if we have got several positions of normal, we need to compare and get the smallest distance there. Now I sincerely hope that you have understood how to find the shortest distance using the concept of normal. And even if there are more positions where we are getting shortest distances, we are trying to compare the two distances and choose the smallest out of them. I thank you for watching this video.